Fine. Welcome everyone into the session on Intro to Serverless SQL in Azure Synapse. And today we have guest as Brian, who is a Microsoft MVP and an MCT, and he will be taking us through the intro to the Azure Synapse and how you can use Serverless SQL to manage it. So without any more delay, we can get into it. And over to you, Brian.
Thank you, and thank you for having me. Let me just start by sharing my screen. Should be this one. Yes, we're good to go. So welcome and thank you for having me. I'm really excited to be able to present on this topic and giving everyone here an introduction to the serverless SQL endpoint in Azure Synapse. Thank you for joining, and let's get to it. There. The agenda for today. An overview of the SQL pool in serverless, how it is built from Microsoft, the cost, usage scenarios, and the code to use to access the server. I will show you how to get started and how to start a Synapse Analytics workspace, spin everything up, and get things rolling in Azure. And to help everyone who has not yet been familiar with the Synapse Studio experience, I'll also guide you on an overall basis through the different UI things in the portal. Of course, we would also do fun stuff, the code and how to read data from different types of data sources. I've brought demos on CSV and Parquet files. The JSON files I've not brought today, even though it is here, but I will show you how to query both CSV and Parquet files. There's also a part in the server SQL pool where I can connect to Cosmos DB and Dataverse. It is not covered in this session, as though it is an introduction session. I'll also show you some tips and tricks on how you get the most out of your setup. Lastly, I'll show you how to get started yourself. The scripts, the demo data, and the slides will be provided in my GitHub account, and I'll send that to Surak after this meeting. Yes. A little bit about myself. My name is Brian. I'm the principal architect of data analytics in Fellowmind, a European Microsoft-based consultancy firm. We do whatever Microsoft is having except Xbox and gamification. You can find my LinkedIn profile here, and I also have a blog at brianbong.dk. If you scan this QR code, you'll be guided directly into my LinkedIn account. As Surak just mentioned, I'm a Microsoft Data Platform MVP. I'm a fast-track recognized solution architect for Power BI, and I'm also a Microsoft certified trainer on Data Platform. If you have any questions, any comments, any things you would like to add or ask, please interrupt me. Just write a question in the chat. If I don't see it, I hope that Surak will interrupt me and ask the questions. So let's get to it. The serverless SQL pool is a mandatory part of every Synapse Analytics workspace. It comes out of the box with the provisioning and are ready to use. It's a pay-per-use service. It costs around $5 per terabyte processed through the service, with a minimum of 10 megabytes. There are some misunderstanding around the cost of Azure Synapse. Azure Synapse, when you use the Azure Calculator, it costs you somewhere roughly around $1,500 a month. That is accurate to the extent that you are using and leveraging the entire platform 24/7 every month. I haven't yet seen any client do that. And with that said, you can actually I've onboarded clients on a serverless SQL pool in Synapse with a monthly cost around $200. So it is fairly approachable, and the cost calculator inside Azure gives you what the maximum cost will be if you use all the services 24/7. So be alert when you use the Azure calculator to do budgeting on Synapse. Well, enough about that. When I say a minimum of 10 megabytes when you process data through it, that means if you do a query and that query only reads, let's say, 5 megabytes, you'll be charged 10 megabytes. But 10 megabytes out of $5 per terabyte is almost nothing. So you could imagine that you can read a lot of data for within those $5 per terabyte. And of course, you need to add to that account the possible data movement to and from your blob storage and the storage inside your blob storage. That is also needed to be added to the overall cost for your Synapse setup. But the detailed process between the data lake and the Synapse SQL serverless endpoint is $5 per terabyte raw. The service leverages the ability to read from CSV, JSON, and Parquet files from data lake. And as I said before, reading data from Cosmos DB and Dataverse service is also possible, but it is not a part of this session. A very, very cool thing about this is that you can use your T-SQL syntax that you know, but with a few limitations. I'll come back to the limitations later. And the approach does not need to copy or move data from the storage account. I'll show you that later in a bit. Well, the cost, I covered that broadly, around $5 per terabyte processed data from your data lake through the SQL Server endpoint. So how does this serverless SQL pool look like underneath the hood? What am I actually getting when I start the serverless SQL point? Well, first of all, I'm either a user or there is an application accessing this data. The data is accessed on a so-called control node. This is the one and only thing I can access from my serverless endpoint. This is also the case if I spin up a dedicated SQL pool. And it is the front end that interacts with all applications and connections from wherever you are connecting. In Synapse SQL, the distributed query engine runs the control node to optimize and coordinate parallel queries. Look at this as the query optimizer and the lazy writer and the execution engine inside the SQL server that you know. Perhaps you know it. This also makes sure that all the parallel streams is gathered and the result set is returned to either the application or the end user, wherever you are. In serverless SQL pool, the distributed query processing engine runs on control node to optimize and coordinate distributed execution of user query by splitting it into smaller queries that will be executed on compute nodes. It also assigns sets of files to be processed by each node, like this. The control node distributes the query to smaller chunks and distributes it to compute nodes. And those compute nodes, you cannot handle how many compute nodes you are getting, but those physical compute nodes then accesses your data lake's files or Dataverse or Cosmos DB. It is the compute nodes that has the computational power. It is the compute nodes that give you all the calculation power, all the select statements, the where clauses, the group bys, the SQL functions that you're using. It is only the compute nodes who is doing that. The control node is gathering all the distributed queries and returning it to the end user. Sometimes, but you cannot control this, but sometimes you will only get one compute node and then you will get a bad performance. If you see that, you can stop the query and rerun it, and very, very often you will get more than one compute node and you will get a good performance. Yeah, the compute nodes store all your user data in Azure storage and run the parallel queries. There's also a service called a data movement service. It is a system-level internal service that moves data across the nodes as necessary to run queries in parallel and to return the accurate results. So what do I get out of this? Well, some of the benefits are a basic discovery and exploration. quickly reason about the data in various formats, Parquet, CSV, JSON, in your data lake, so you can plan how to extract insights from it. A logical data warehouse provides a relational abstraction on top of raw or disparate data without relocating and transforming data, allowing always up-to-date view of your data. If you want to learn more, I'll provide you a link in the slides to Zorak, where you can read more about the logical data warehouse. I'll also come back to it later on a short notice. Data transformation, simple, scalable, and performant way to transform data in the lake using T-SQL. So it can be fed from the serverless endpoint to BI tools like Power BI or other relational data storages like Azure SQL database, wherever you want your data to be delivered. If we look at it as a role-based approach, then as a data engineer, I can explore the data, I can transform and prepare the data using this service and simplify the data transformation pipelines. If I'm a data scientist, well, I can be provided with the raw, uncooked data, and I can very quickly get my data frames into my AI machine learning, and from that get an automatic schema in inference, so that when data is updated at the data lake, well, the data scientist will get that new data format when it is needed. And data analysts can quickly explore the data, and if he or she is a Spark is proficient in the Spark service, he or she can also create external tables and use the functionality within Spark wherever needed. Lastly, but not least, the BI professional can, of course, create Power BI reports on top of this data in both the lake or in the Spark tables provided by the data analysts. The T-SQL support. Well, the T-SQL supports DDL, data definition language, databases, schemas, views, and store procedures. You cannot create a table, a materialized view, or function. This perhaps makes sense as the serverless SQL server does not have any storage account. It resides only on the storage inside your data lake. So you cannot create a table with a small caveat there. I'll get back to that this later on a so-called external table called a CTAS. I'll show you this later. The security. You can create login and users, credentials, grant, deny, and object levels, AAD integration, and all the security stuff that you would need for a hardened setup for accessing data, as on the same exact level as a normal T-SQL server. The data manipulation language is almost a full support for the select statement with a minor subset of features that are not yet available. One of this example could be a recursive CTE, where you have a common table expression that has a join into itself to perhaps unfold a parent-child hierarchy or whatever you need. That is not yet supported inside the Synapse serverless SQL pool. Besides that, you get a full select statement support with mean, max, largest, smallest, all those stuff inside your serverless SQL pool. So a short demo. How do I create a Synapse workspace? Let me go back here. Here I have my own Azure portal. Inside this, I have a resource group called APAC Synapse Demo. It is right now empty. So let me create a resource. In here, I'll search for Synapse. You'll get two resource sets when you search for Synapse Analytics. The first one is a private link hub. You don't need that right now. It's out of this scope, but you need the Azure Synapse Analytics workspace. Let me create that one. Now you will be presented with the setup guide. Of course, this is also applicable if you use Bicep or ARM templates. You can do this, but right now, let me just use the guide. When you start up a Synapse workspace, it needs a managed resource group. The managed resource group is a specific resource group used to manage which Azure uses to manage the service inside Synapse. So you need to give this a name. I think it has some Synapse demo, managed resource group. And now I can give it my workspace name for whatever my workspace should be named inside Synapse. Let me call this Synapse Demo APAC. I'm going to say lowercase. Thank you. Synapse APAC Demo. The region, I'll choose Western Europe because I'm here in Denmark. I also need to provide it with a data lake storage. I can either bring my own or I can create a new one. Here, I would like to create a new one. APAC data lake. It's okay. And I also need to provide a file system. I'll also create a new one. APAC file system. There you go. Make sure that this tick mark is on, because then I assign myself to the needed access level to both the storage account and the file system in order to access the data from the Synapse Studio. You have a few more setups to do if you would like to go into details around security, networking, and tags. But for the ease of this demo, I'll just go ahead and hit review and create. Here you will see this is in Danish kroners. This is a very, very small amount. In US dollars, this would be around $7. This is the estimated cost per terabyte. So $5 US for whatever data I'm pushing through this serverless endpoint. There's a lot of terms, and you can see the setup of the things here. If I hit create here, then now Azure will start to provision all my services. I can follow the screen here to see what is happening. While this is running, I'll show you what is actually happening behind the scenes. Here, I have asked my Azure portal now to create a Synapse Analytics workspace. It is the top one up here. It then now creates the managed resource group to take care of this Synapse workspace. It also creates the Azure Blob Storage and the serverless SQL endpoint. This is more or less just an SQL connection string, and it then connects the two to be able to read from each other. So now when this service is done, the serverless SQL endpoint is able to read data from the Azure Blob Storage. Let me show you this. Now the storage account has been made, and the file storage has also been made. Now it is provisioning the Synapse workspace. But in order not to miss time, I have already created one, and the next thing is to give you a quick walkthrough of the Synapse workspace. So let me just go back here. This is now provisioned, and this is the default view of my Synapse workspace. In here, in order to access my actual Synapse workspace, I need to click this Open Synapse Studio. Open. It opens in a new window. If you would like a direct link to this one, you can copy this URL, and then you can save it as a favorite, and then you will be guided directly into this. From here, this is my default view on a Synapse workspace. I have default access to ingest data. The ingestion part is the Synapse pipelines. Explore and analyze. Here, I will be able to browse my data and do right clicks and do select whatever. I'll show you that in a minute. And there is also a possibility to add your Power BI workspace in order to build data sets and reports. On my left, there's the home button. This is where I am. There's my data button. In the data button, I'll see my linked service is here. I can browse my folders to see the data that is there. I have already loaded some data here. I'll come back to this later. Develop, I can do SQL scripts. I can create a new SQL script. I can do a new Custom query script. I can do a new notebook, a new data flow, Apache Spark job, and so forth, and so forth, and so forth. I can also do a new Power BI report if I need that. Integrate part, this is the pipelines. I can create a new pipeline. I can create a new link connection or copy data tool. In the monitor part, I can see my SQL pools, what is running. I have a built-in serverless. There's nothing else here. If I would to create a dedicated pool, this will also be shown here. I can see my Apache Spark pools if I have any, my Data Explorer pools if I have any, my SQL requests. This is right now empty because within the last 24 hours, there has not been any request. But if I go back a month, perhaps there will be some. Yes. Here I can see all the requests that has been done. I can see the actual select statements. I can see how long time it took, at what time of day it was, the amount of data processed. And here you will see this one is 10 megabytes because the amount of data was less than 10 megabytes. So this will cost me at least 10 megabytes. I can see who did it. It was me. It was completed. And the session ID is not right now available. So from this, I'll be able to do reporting and do surveillance on who is doing what inside my serverless SQL pool. I can do the same on Custom query. There is none here. The Spark pools and so forth, the pipeline runs, trigger runs, and all those stuff. In the manage, I can do a lot of stuff around managing my serverless. My Synapse workspace. I can see my SQL pool. I can create a new one. If I want a dedicated SQL pool, now it begins to cost me money per hour, not per data processed, but per hour. And I can create Apache Spark pools, link service, and all those stuff. But as a start point, you would mostly be in your data path, your develop path, and your integrate path. The integrate path is not a part of the serverless endpoint. It is just a leverage of more or less the same functionality as you get out of Azure Data Factory, with there's a small gap between Azure Data Factory and Synapse, where Synapse cannot do the entire functionality as Azure Data Factory can. So this is the quick guide. And let me see what we can do with it now. I can query my data using the Synapse serverless endpoint. I can query CSV files, Parquet files, and JSON files. And the CSV part support all formats from the CSV part of the world. Some formats that have special configurations like pipe as delimiter, some text qualifiers, and special line ends / new lines need special configuration in the SQL language, but they can all be queried from within the Synapse Analytics workspace. Parquet files, if you don't know it, Parquet files is a standard file format with a built-in const index. It is a compressed file format, and it is also directly applicable and can be used without further configuration. JSON files is more or less the same pane, if you would, as the normal SQL. It is supported with the OpenJSON syntax, and you still need to define all your cross-apply and auto-apply to get things to work for you inside the JSON format. So there are no silver bullets in Synapse SQL serverless as you might wish for. If you know, if you work with Spark and the Spark notebooks, then you know that the JSON unfold or explosion is done by just dotting your way through the syntax. This is very, very easy, but not a part of the Synapse serverless SQL endpoint. So how do I query my CSV, JSON, and Parquet files? Well, as I showed you before, here I'm able to actually browse my way through my storage account. And to show you what I have, I'll just bring in my Storage Explorer. This is the same thing. This is my SQL code storage. This is my playground. This is the NYC taxi. And if I unfold this one, you'll see I have the same for folder structure, AdventureWorks, Airbnb, NYC taxi, and so forth. In here, I have loaded some data for CSV and Parquet files. And from this, I can actually, if I'm just lazy, in my CSV files, I can right-click, new SQL script, and select my top 1,000. Top 100, sorry. Let me just give myself some white space here. I'll get back to what these things are, but now the serverless SQL endpoint is accessing my storage account on this folder and this file here, and returning the resource set to me. Please notice that the headers are not actually adhered to as headers. I'll come back to this later, but I can query my data as I would any other data source in a SQL server. No, I won't do that. If I have a Parquet files, I can do the same thing. It gives me the same result set, but now, as with the Parquet files, the file structure and the metadata for the storage is given. So now the headers is adhered to. And there you go. So when you query your CSV files, you have one of two parser versions to choose from. The parser version 1 is the first parser version that Microsoft gave to us. It is somewhat very, very slow compared to the parser version 2, but the parser version 2 has some specific needs. It has the maximum character limit of a column must be 8,000 or less. A row size must be a maximum of 8 megabytes, and all the other stuff that you can see down here. If you do not specify other things as the default terminators for a row, then it will use either character return or new line. If you want to use dates, you need to in a very special format like year, month, date, and the time in hour, minute, seconds, and fractional seconds if you need that. If you have any other date formats, well, the parser version 2 is not applicable, and you need to go back to parser version 1. There's also a possibility to do a CTES, create external table else. It is actually a functionality where you can read data from any source, CSV, Parquet, or JSON, and save it as a special Parquet file in the data lake in a specified folder. The usage of the could be to provide a pre-calculated data set if the data set in the view is too slow for the end user to access or Power BI to update, then you can, during the night, recalculate your CTES with all the calculations from your view and expose that table to the end user. I'll show you this in a demo right now. Where is my browser? I lost my browser. Where is it? There you go. Here it is. So the demo code. Let me just create a new database. Notice that I am explicitly specifying the UTF-8 collation on this database. This is because my CSV file are UTF-8 formatted. And if you saw when I did this select statement on the CSV file, just run it again. You see that I get, whoops, sorry. You see that that I get these it's not an error. It's just a hey, you need to look at this. It is a notification that the CSV file is UTF encoded, but my built-in master database is not UTF collated. So I'm creating a new database called APAC Demo with a specific collation of UTF-8. And here you will see that when I'm accessing my serverless SQL endpoint, I can do whatever I would like to. I can create a new database, I can create a new user, I can create whatever I would like to. You can just use that new database. The experience in the web is somewhat slower than it would be in Azure Data Studio or SQL Server Management Studio. That is just a given fact. When you access this through Azure Data Studio or SQL Server Management Studio, you will see the normal performance as you will see in any other SQL Server database. Let me create a schema. And in order for me to do a select statement, in order for me to create a CTES, create external table as, I need a scoped credential. And in order to get a scoped credential, I need a master key encryption with a password. This is just a default password. So let me create that. And when I create a scoped credential, this is needed for Synapse to write data back to my storage account. Right now, the setup from Azure default is to only read it. Now, in order to give Synapse access to write to it, I also need to give it a scope credential. In order to give it a scope credential, I need a secret. This secret is found on, let me go here, on my storage account. This is the storage account. Then I need to go to access keys. No, sorry, to shared access signatures. And here define what is allowed with this shared access signature. I need to give it a time span. Let me just do it from yesterday to tomorrow and generate it. Down here, I'm giving 6 different connection strings. The one I need is the one called SAS token. Let me copy that. Back to this one and paste it. A small thing you need to know here, when I default copy and paste this, it adds the question mark. You can also see the question mark was right here. This question mark is not allowed for a shared access signature inside Synapse, so I need to delete this one. Run it. There you go. And to create external data source in order for Synapse to write data back to the storage account, and the external file format as a Parquet file. There you go. And here I'm just creating a view on top of the New York City taxi dataset on all the Parquet files. But in order for us to have enough time, I'm only doing it on a small dataset. This small dataset is a subset of, this is the entire Parquet files. I have 164 files in around 400 megabytes. That's a lot of data. We don't have time to wait for that. So I have made small data sets with 2 files on Parquet files and 2 files on CSV files. This is only for demo purposes. So you will see here, I'm using the Parquet small data set. Here I'm creating a view. Run. Here I'm now creating the external table on the Parquet files. You can see I'm creating the external table with location. This is where I want my files to be stored on my storage account. The data source was the data source I just created, and the file format was the file format I created. And then it has an as, and then I can do whatever select statement I would here. This could also be a select from a view, from this view up here. But right now I'll just do it on the same data set. So, and this wasn't working in last time I did it, so let me hope this works now. What Synapse is doing now, it is reading the data from these Parquet files and writing it back to my storage account. And it is still running, but let me show you. It has created this folder, all Parquet external table. It is the same folder as you can see right there. Inside this folder, it is now storing the Parquet files as needed. It is still writing them. Let me just see if it is done. It's not done yet. It is still writing them. And the number of files here you cannot control, but it is a rule of thumb is the number of files here will be the same number of files as you have in your source. So if I had 5 Parquet files, it would save 5 Parquet files here. If I had 1, it would save 1. If I had 1 CSV file, it would save 1 Parquet file. If I had 100 CSV files, it would save 100 Parquet files. It's just the default behavior of Synapse. There is functionality to do. It is called vacuum on your Parquet files, so it is adhering to the best practice from Microsoft. Rather have fewer bigger files than a lot of small files. Let me see if it is done. Yeah, you can see now the files are done, and it fills more or less the same amount of data because it is already stored as Parquet files. Now it is done, and I'm actually able to read from it. Let me show you how. I need to go there. Demo here. In order to access my serverless SQL pool, I have this connection string. I can copy this, and I can add it to my Azure Data Studio. I've already done it. I connected to this before I did the demo. There is not a database yet called APAC demo, but if I refresh it, it should show me. There you go. The APAC demo. I have now the view I just created. I can do a select. It runs. And here you will see that the performance here is more or less this on par with a standard SQL Server. Compared to what I did in the UI, the UI is just slower, but as it is. But I am now also giving the external table, and I can also do a select from this. The data is given back to me rather faster because the external table is using the Parquet files in a built-in connection between the Parquet files and the Synapse workspace. So this is rather faster than comparing to a Parquet file view. But what happens if I then do a view based on CSV files? Well, here you'll see I'm using the parser version 2.0. I'm giving it a first row equals 2, so it skips the header row. When I do this, I also need to provide it with the header names for this file. So here I'm creating a view that reads all my YellowTrip data wildcard CSV files. So all my CSV files in my small data set with a wildcard on the file name. I could also do it like this. Then it was just read all my CSV files. In this demo purpose, there is no difference between YellowTrip data and without YellowTrip data. But just for the demo purposes, I will show you that the wildcard is actually applicable. The format is of course CSV, and let me create this for you. There you go, and back to this. Refresh the view, and now you will see that I have an all CSV, and this is also quite okay on the performance because the CSV files in a Synapse connection is actually able to do performance optimization on the readings on the CSV files. Synapse cannot do performance optimizations on Parquet files that you add on a custom view. It can only do performance optimizations on Parquet files that you use as an external table. It's a bit out of the scope for this session. I have another session on my last slide where you can see it on the video on what to choose when CSV, Parquet, external table, and so forth. But now I can begin to do whatever I would inside my data. This is still raw CSV file. No data is moved. I can do a count star. I can run this. I can do the same thing on my Parquet files. And you will see that some statements are faster on Parquet than compared to CSV. Here I'm giving the same resource set because the data is from the same source. But I can also do select some of. I need a column. Some of. What should we do? There, fair amount. Fair amount. Vendor name, group by vendor name. This is still accessing my raw data saved as a Parquet file as an external table. And I can do whatever I want to it with the standard T-SQL syntax on my data. Yeah. So back to the PowerPoint. When you have seen this CETAS demo, you would also know now that the CETAS is reading data from the data lake, saving it as a Parquet file, exposing it through the SQL endpoint through Synapse Analytics to the application or user. If you think about this a bit, then you will also see that based on this, I can start to begin to build my virtual data warehouse. I can read my data from my raw format, CSV, Parquet, JSON, save it as an external table, do data manipulation on that table, save it as another external table, do data manipulation on that, and so forth and so forth. A small thing you need to know here is when you create an external table, the folder name is reserved as a folder name inside Synapse. So you cannot reuse that folder name unless you drop your external table and delete the folder inside your storage account and recreate the folder based on your create external table as, then Synapse will proceed with processing your data. If you do not delete the folder inside your folder structure in your storage account, Synapse will not allow you to create another external table, even though the folder is empty. So please remember to delete the folder inside your blob storage when you are done, or do it inside your pipelines for updating all your data. Small tips and tricks. If your CSV file is UTF formatted, then use the UTF collection on the database I just showed you. This helps and removes a lot of frustration. Try to use parser version 2 when reading the CSV file. It is so much faster, but as you saw on some of the previous slides, it needs specific formatting on the CSV file. You can try it out for yourself. This is the link to my GitHub. You will see there will be a folder called APAC in this tree structure, where you will find the slides and the demo scripts for you to try it out. There's a small thing you need to change the address of your storage account, and you need to change the SAS token because those are mine, and you need to provide it with yourself. Data is free to use and come from the public text data endpoint. You can see it here, Parquet and CSV. And I tried to provide you with a JSON file from my own blog, but for some reason today I cannot export that for JSON. So yeah, that's one of the things that comes out of building your own blog in your own spare time. So, do you want to see more? Well, there is a lot of more into the Synapse world. On the left side here, my good colleague Matthias has a YouTube video, Supercharged Power BI with Azure Synapse Analytics, where he joins with Reed Havens and shows how Synapse can actually leverage the Power BI universe directly inside Synapse on a unified experience in the web UI. On the right-hand side, there is my own session I did at Data Toboggan this fall, last year, where I'm comparing the CETAS that you just saw, the views and the Parquet files on what to choose when, and knowing how to implement them. The links are here, and you can see it on the GitHub in later today. Do I have anything else to show you? No, I think I've went through it all. So this should be the end of the slideshow. And if you have any questions, I haven't been able to watch the oh, there is a comment there. Give the GitHub link here again. Oh yeah, Nevas. Yeah, sure. I'll just go back. It is there. Sure. The certificate link. Oh, that's not for me. Sure, Nevas.
Thank you, Brian, for the session. Certificate link will be shared shortly, so we still have a little bit time to discuss if there is any question. There was a bunch of things that we ran through the demos. If there is any question, I would you can type it up, and if you want to have mic access, you can let me know, and I can give you mic access as well.
Yeah, just don't be afraid to ask questions, because now is the time to get your answers.
Yes, definitely. So we have Brian here with us already, so it's a good time to ask so that he can explain it right away.
Yeah. So I see a raised hand. Is that something we need to from Saad?
Okay. Saad, if you can drop your questions, that would be great, or let us know what is the question so that we can answer. And also, the few links related to Azure Synapse is there in the QR code, which is displayed. You can check out if you would like to learn more or check out the Azure data or Azure resources on Synapse. Okay, I guess nobody is having any questions.
There was this raised hand from Saad. Perhaps he.
Yes, but the question we need to know that, right? So,
Yeah, sure.
or we can I can give mic access. If you want the mic access, please do let us know if
So
that's
there is actually a question from Nevas. I'm sorry if I don't pronounce this correctly. So the CTES table will be created once on single instances. If I understand this correctly, then the CTES table will be created once you execute your query, and then the data will be stored inside your storage account. And it is only instance, you only have one SQL instance on your serverless SQL endpoint, but you have the ability to make as many databases as you would like, up to a limit of 255 databases. I hope that is enough answer for you, Nevas, or else just let me know or reach out to me from LinkedIn, and I'll gladly chat with you about this.
because that's it. There is no more questions or any queries.
share your LinkedIn. Yeah, sure. Just hang on. It is no. Hang on. There you go.
Guess that is it. If there is no more question, we can end the session, go on with the day. Okay,
Yeah.
thank you, Brian, for the session. It was really resourceful, and it's great to have you, and hope to have you in the community again and on a
Sure.
different topic.
Sure.
Okay.
I'll gladly help.
Thank you everyone for joining as well, and see you in the next session. And if you would like to join other session, we have on topic on Teams next. Thank you everyone. Thank you, Brian. See you.
Thank you. Bye.